while joins merge data horizontally, just as if you took the result set from the first query, printed it out, took the result set from the second query, printed that out, and pasted the two together vertically. In fact, looking at the syntax, it looks just like that. So here's the first query, and I'll execute. We're simply selecting first name, last name from CHA DBO customer table. The second query is selecting first name, last name from OBX Kites DBO contact table. So two separate queries. They have to follow a few specific rules. The queries have to have the same number of columns. Each column has to match up in the same basic data type family, so you can't mix integers and strings. The first query provides the name for each column, as illustrated here with the alias. The very last query, or at the end of the entire union, there's the order by. And I've added an expression to each one, just so that we can know where it's coming from. So the first query has an alias to identify that column for the expression, and there's no alias required for the second query because that's not where the column names come from. So we'll go ahead and execute this and open it up so we have some room. And sure enough, sorted by last name, first name, here are all the customers merged together from CHA and from OBX Kites. If we didn't have the order by, the process of merging them physically still makes it look like it's sorted, but it's really not logically sorted in a way we defined. Another fine point to working with unions is that it's the opposite of the select. Remember in the select, it was select all by default, and we had to specify select distinct if we wanted to eliminate duplicates. The union is the opposite of that. It is a union distinct by default. So by default, it will do another step to remove duplicates from the union. Because there are some last names that are common between the CHA customer and OBX contact, this is a good example of proving this. So if we go ahead and run this query, we find here are the distinct names between them, and there are no duplicates in this list. However, if we say union all, then the duplicates can show up, such as Adams, Andrews, Davis. And it's important to note that this distinct or all takes place only in the final result set, not in the underlying data. So one performance tip is if you really doubt there's going to be any duplicates, to say union all, just to save that one extra step. And new to 2005 is the union intersect and the union except. The union intersect finds only those that are common to both, similar to a join. However, it's not doing a horizontal merge, it's doing a vertical stacking. But it finds only those, in this example, last name, that's common to both. And those were the duplicates we saw before. The except is like a difference union. It finds only those rows that are in the first select or in the second select, but not common to each. Intersect and except are ANSI standard versions of the union. They're new in the implementation in SQL Server 2005. You could perform an intersect and except back in SQL Server 2000, but it would take some subqueries and jumping through hoops. So in this lesson, we've looked at inner joins, also called natural joins, at left outer joins, how to join two copies of the same table, different ways of doing unions, and it's this ability to merge data together from multiple tables that's really the heart of SQL. Because relational database has a tendency to break information apart into multiple normalized tables, knowing the schema and knowing how to pull the data back together in the from clause is key to being able to build powerful set-based solutions. In my opinion, the most powerful features we've talked about so far in building set-based queries would include the case expression, the inner and left outer join, and these can be used to build powerful queries that can solve complex problems.